Now this is for homework number 13. I think, let me double check. Homework number 13, comparing two groups, question number 9. So let me go over this one with you. Teaching assistant collected data from students in one over classes to investigate whether study time per week, average number of hours, differed between students in the class who plan to go to graduate school and those who did not. Complete parts A through C. Click the icon to view the data, okay? So there's the data right here. Let me go ahead and send it straight to StatCrunch so that we can work with it, okay? So this is good that we just got it open on StatCrunch. Got two screens open right here. So let's take a look. Find the sample mean and standard deviation for each group. Interpret. Now you know how to do this. You've done this before, but it just sounds so new in a brand new unit, right? So let's take a look. You know how to find the mean and standard deviation by going to Stat, Summary Stat, and Columns. Okay, you've done this, I think in Unit 1 when we find like 5 number summaries, different things. But go ahead and go to Stat, Summary Stats, and Columns. And then just click on both graduate school and no graduate school. Okay, I'm going to go ahead and click on mean and standard deviation by hitting down my command button or control key if you want to select more than one thing and compute them. Now here we go, we found it. The mean is going to be 11.57157 for the first group, graduate school group. So let me go ahead and type that in and click on check answer. Why is that button running away from me? Let me see. Try to zoom out. And that is how you find the mean. Let's see, what else do we need? The mean of the second group is 9.1. So they study a little less, huh? Maybe they're not going to grad school, so they're not studying as much. But we also got the standard deviation for students who go to graduate school, who plan on going to graduate school. And that standard deviation was 8.13 for group 1 right here. And then the other number was 3.63. So what we can say is that, interpreting the value now, the sample mean was higher, right, for the people who are planning to go to graduate school. But as you can see, their standard deviation was also higher. So that means that we're talking about there's more variation over there. So let me see which one is saying that. Sample mean was higher for students who plan to go to graduate school. I like what I see on D over here. The sample mean was higher for students who plan to go to graduate school, but the time were also much more variable for this group. That means higher standard deviation. So D sounds like it. Higher the number, the standard deviation is, that means more variable it is. Find the standard error for difference between two sample means. Now we're doing something a little different because what we just did was just descriptive statistics. We just described the data for the sample 1 and sample 2, but now we're trying to find the difference between these two. And we're not about to just subtract them one by one. So what I'm going to do is I'm going to go ahead and, let me first zoom out. I'm going to go ahead and actually do two sample test over here. Click on Stat. And this is what we went over in class. I think you can find the Zoom meeting recording for this, but I can also go over this with you right now. So go to T-Stat, and we talked about, without knowing the population standard deviation, we're going to have to do T-statistics or T-test or T-confidence interval for population to estimate population average. And for this data, we got two samples. So T-stat 2 sample and click on with summary. We have, not summary, with data. We got data saved in row 1 and row 2. Column 1 and column 2. Click that the variable 1, sample 1 is in graduate school column and sample 2 is in no graduate school. And I don't know which one we're doing. I don't know if we're doing confidence interval or significance test, but I'm just going to go ahead and make a 95% confidence interval. The reason I'm doing this is because I just want to see the standard error. Notice there is a standard error given for us right there. And this is the standard error for difference between two means. Okay? And that's what they wanted. They wanted you to find the standard error for the difference between the sample means. So we're going to go ahead and say that the standard error comes out to be 2.11. Right there, 2.11. And let's go ahead and interpret this. Now, what does it mean? Now, if you keep on taking The same size sample, what were the sample sizes? So sample sizes were, let me go in and zoom out, 21 for graduate school and 10 for no graduate school. So if you keep on asking 21 students who plan on going to grad school and 10 students who don't plan on going to grad school, and if you keep on taking the same size sample, they're gonna have differences, right? If you keep on doing that, they're going to have their own distribution. They're going to have a variation because it's not always going to come out to be 2.47. Okay, so what we were finding is that when we did the average student, how should I say this? The average number of hours they study if they're planning to go to grad school minus the average number of hours they study for the group of students who don't plan to go to grad school. If you subtract them, it's going to be about 2.47 hours. But that number isn't going to be the same because we're going to have sample variations, right? So those numbers will have their own distribution, and this is going to have a variation. And that's what standard error is. So the further random sample of these sizes were obtained from these population, the difference between sample mean would vary, right? They're gonna vary. It's not gonna be exactly the same. Because I'm not going to pick the same 15 people, same 10 people. We're going to pick different people, and different people study different number of hours. The standard deviation of these values for x1, their difference in mean would be about 2.11, and that is that number right there. So that is how you interpret these standard error for the difference between the sample means. Now what's next? Now listen, I was lucky because I just randomly did a confidence interval for 95% confidence, and I got the lower limit already. That's what they're asking right there. What is a 95% confidence interval comparing these population means? Rounded to the nearest tenth, I'm gonna say my lower limit is negative 1.9, and my upper limit is 6.8. So that's my confidence interval, and we talked about that specific number, right? Now, if you look at that confidence interval, it goes down to negative and it goes up to positive. What number does it include? It includes 0. And what does 0 mean? 0 means there is no difference. So we'll talk about that soon. But first of all, let's interpret this confidence interval. We are 95% confident that the difference in mean study time per week between two groups is between negative 1.8 hours and 6.8 hours. Now, I think they're talking about, okay, so A and B are absolutely good for the first sentence. C, I think they're trying to, remember we talked about how 95% confidence interval and 5% significance level test will give you the consistent result. But we are 95% confident in this. We're not 5% confidence. So cross out C. C is not good, but it's either A or B. Let's take a look. One cannot conclude that the population mean study time differ for the population group. Now, I like that one. Why? Because listen, in this interval, from negative to positive, what we are saying is, hey, 0 is a plausible answer, 0. And think about difference of 0. Now, if they are the same, they have no difference, right? If they are the same, if you subtract two of the same thing, you're going to get a 0. So what this confidence interval is saying is that we're 95% confident that the true difference between these two mean is going to be in between these negative and a positive number. And this interval is including the number 0. What that means is, hey, they may be the same. They may have no difference. So we cannot conclude that the population mean time differs. Because if they are different, they're not going to include 0 in their interval. So you get to say something like B, that they are different. If your confidence interval is completely positive or completely negative, in other words, if they don't include 0, you can say that they are different. But as long as, if you get a confidence interval that is stretching down to negative for the lower and positive for the upper, then there's no way for us to say that they are different, okay? Because they could be the same. So that's how you would do this one. Definitely click on similar question to try this because we went over this one together. I'm going to go ahead and answer all the other ones soon and send you the YouTube video link, okay?